pause the recording. That's great.
Yeah.
Подходите тоже. So we have 2 people here. Included, yes. Wait it a little bit.
I was exploring some abandoned sanatoriy around Kutaisi, and I found this in there.
Yeah. So good.
It's like a Soviet thing.
Extra individual
And we use it to put like cigarettes.
But it has like a compartment there for like what, nuclear, to protect yourself from radioactive substances.
Yeah. There was like a little label here, but now it's removed.
And the bottom, like there was something, you know, like painkillers, radioactive substances.
I actually
you
hear.
Are exposed. Take this.
I hear that there are pervitin. It's methamphetamine.
Ah, yeah.
Here.
What?
I
Matches the radioactive?
No, I hear that in this kind of box exists methamphetamine.
Yeah.
for some reason.
Cures all of the diseases.
Yeah. Ah, so you wanted to actually. So you asked for some part before I will continue.
Yeah, basically Sneh finished a piece she's been working on for like a couple of weeks now, and I just want to show it just to kind of break it up. And can you say something about this piece? What was it about, and why did you make it?
Yeah. Okay. Well, I've been working with this girl from St. Petersburg. She does like she has like a very interesting musical brand called Kiki Yago, where she's kind of like this character that exists in some weird cyber metaverse, and she sent me a few songs, so I've been making music videos for her, and this is just one of them that I made in Unreal Engine with Madison. Yeah. Can you turn the light off?
Yeah. Look at all these normals.
Wow, like you can do real close-ups.
What's that?
You can do real close-up shots and they don't look like shit.
Yeah.
Cool.
Yeah, this is just, it's like
And
There,
what-
she has this one song called Yakiki, and I did like 3 different sections for it. So this is the third section. So
Where,
it's not like the full song, but
where did you get the face capture?
it's from her.
It's like just a footage of her face, or she tracked her face with like real
With iPhone.
with iPhone. That's
Yeah.
it. Okay.
And she's in St. Petersburg, so she did this recording for us with her iPhone and this app. And then we took that, Snake took that recording and applied it to MetaHuman in Unreal Engine, essentially.
Okay, I get it.
Anybody come to see your ass, so it's a different no, non ma sei bacini da parte,
Another
questo
one
mi
of
dice,
your
ma
songs.
stai adesso pagari, follow it's a bit, no, anybody come to see your ass, so it's a different no, non ma sei bacini da parte.
I like this so much, actually.
You like the hat?
Yes.
This is so we had like an idea to.
Scroll down low. There's some other version of it.
What? What is it?
So we made a music video for this song,
Okay.
Siroha, and like we had this idea to like take the costumes from the song and then like make them like little entities.
Here? Here?
Mhm.
Here?
What?
You can take some
yeah.
inspiration from bike helmets.
From bike?
Bike helmets.
Yeah, I know. Oh, this is actually part 2 of that same song. Kind of a very different style.
Triangles.
Yeah. I actually like this one, really.
The hat?
Yes.
Yeah.
So this one is really.
You like the.
Yeah.
And where do you control the animation of the growth of those feathers? It's
Where?
like one follow control.
I think
Unreal?
she created it.
Yeah, this is.
Or is it a baked animation?
No. It's
It was
created
me-
by I don't know, by hand. I
By
think.
hand?
By yes.
No.
No?
It's procedural. It's a,
Okay, it's procedural, but it's created. It's like a formula that's
Yes.
created by hand.
Yeah, I know, but to animate the growth, like
The growth is always created by
Yeah, I know, but
by a formula.
yeah, I know,
procedural.
but
And this
you
one,
in Unreal Engine, you have a field, like
No, okay, so this.
you
Yeah.
move it and it grows like this.
Well, this was actually done in Houdini.
Yeah.
So like basically I had there was like one simple line that I drew, which is just like, from the back of the head to the front of the head. And then from there I can animate like another geometry on top of it. There's like this line, and then there's also the lines going up. And then I kind of like spawn them in one by one based on how far they are from the beginning of the spline.
So the animation was from Houdini.
Yes.
Oh,
Yeah, and then
okay.
I brought it in like Olympic cache into Unreal and just like played it. But you can't really do that kind of stuff in Unreal.
I'm interested in like MoGraph stuff in Unreal.
Like what's it?
Like in cinema MoGraph stuff, like when you just enlarge one sphere and everything moves inside the sphere according to some rules.
Yeah.
So does it work in Unreal? I can show you
Yeah.
what
Wait,
I'm talking about.
you move a sphere and what?
Yeah, I haven't shown you.
Oh, this is
SDS?
Yeah, let's go to SDS.
yeah. Let's go. Actually, I not have so much. Maybe.
That's okay. It's good to know what SDF is and that it exists.
Yeah. That they exist and how it works. I think.
Oh my gosh, I see Iniko Kilas. these words.
Yeah, yes, exactly. So where actually? Oh, okay. So we go to part of SDF functions. It's called signal distance field actually. And what does it mean? What does it these three words means together? It means that we can make a function that is positive on outside and negative inside of some shape. Yes, and we can make this kind of functions. That means that if you, for example, in some point, and it's a field also. This means that if you in some point so when you place this point into this function, you will get a distance to the shape, positive if it's outside of the shape, and negative if it's inside shape. For example, we have a shape of round square, round circle, and if you have a point outside of the circle, we have a distance to this circle. And if we have a point inside a circle, we have negative one distance to the circle. This is we can calculate this distance for a circle. For example, is really simple. It's length of p minus r. R is the radius. Yes. We can calculate SDF of some font. Actually, the problem of rendering different fonts, it's kind of not easy problem how to render fonts properly. That's why a lot of fonts is created by SDF texture, and this is a real real case how fonts is working on a computer GPU. So at some point it decides that letter A, for example, is starting here on a level of 0.5, and the problem of a font is anti-aliasing. When you properly drawing a font, and how you render this font, different letters, and how it blended with background. So this is a complicated thing. That's why usually you have some kind of SDF texture, and MSDF sometimes is a special thing for fonts exists also. So we have this kind of functions for SDF. Here, for example,
looks like 3042.
yeah, so we have a website to this guy. So in EQS we have different kind of functions that is fit for SDFs. So we have a rhombus, for example, triangle, some kind of drop, hexagon, stars, and this kind of shapes. So you can use it in quadratic Bezier is very useful things actually. So also in 3D, so it's a sphere, it's kind of box, a frame, torus, carpet torus, cylinder, cone, all of these things that you can use. And why is these functions actually useful? Because you can do a sphere tracing with it. It's called also ray marching. It's actually, this is very popular word, how they call it, but in the papers, in scientific papers, you usually looking at as sphere tracing, is they call it like that, because ray marching is, I think this term is created by Inigo Quilles, and that's why it exists. So in a public sphere, publicly everyone is knows it as ray marching, but actually if you want to look at some scientific papers, you usually call it like sphere tracing. What does it mean actually? Let's go to this trajectory to understand what is going on. So it is possible to create a scene that is encrypted. It is encrypted into math. For example, here you can see 2D plane and a little bump here, and also a circle, and the circle inside is divided by from it. And how the ray marching is working, you can see here. So here is a light that going, and it's heated. It's heating at some point. So so it's kind of ray tracing, but it's not a ray tracing. It's much better than ray tracing. So maybe I can find a better picture. So for example, we have some environment. So we have some 3D fractal or 3D model, and we want to show it on the screen, and we want to render it. And for some, for example, for each pixel we want to understand what's going on with this pixel. And the process of SDF, the reason why it's so cool, because we don't usually with ray tracing, for example, we go in with the same amount of steps here. For example, 1, 2, 3, 4, 6, 7, 8, 9, and 9 is going into 3D shape, and it's already not for us, for example. But what ray marching is doing? It is a field that is can be calculated from any point of space, and each point of a space show exact amount of distance that is show close point for this for your object. So for example, if we have a camera here in this point, we have a distance here like this. So this sphere, we can draw this sphere and go, instead of going an exact amount every time, we go exactly to this direction, and we know that we don't have anything here because we have this kind of rule that we have in each point of a space we have one amount. We have a distance to closest part of your object. So here, for example, in this example, we can go here and we can draw another circle, another distance, closest distance here, for example. We can draw another circle, we can draw another circle, we can draw in these circles. And these concentrated circles is becoming more efficient algorithm how to render things. And that's why ray marching is used for kind of fractals, kind of this kind of things. You see, this is called Mandelbrot cells, yes. Oh, what the fuck? And so yeah. So this is how it looks like in real time. For example, so you can see that this is a distance. This is functions of a distance. So when array going through this, it is showing what distance you have. So the first time you have this kind of distance from here to here. Later, when you have this bump, distance is decreasing. Distance is decreasing, then it's increasing again. So the steps is going bigger, and then when you go into this hole, distance again is becoming small, and later is increasing, and then also decreasing, and then it's going in negative way in a negative direction, because its signal distance field is sign is negative here. So actually it stopped here. You can change it and look how it differs.
So what can you do with those DFs?
You can do so with SDFs. You can do actually this kind of ray tracing, but it's in more efficient way.
What can you do with ray tracing?
But with this example, it looks like an idea for some pattern generator. Like, have you seen Arabic patterns?
Arabic?
They are most of the time circular, and they have lots of reflections of one specific line. And if you use like 16 of those lines, make a beautiful geometry where they can bounce, and then you move the lights, move the geometry, it's a beautiful pattern.
Was it called Arabic patterns?
Well, no, any patterns.
Any pattern.
Yeah. Arabic patterns have their own mathematical rules. But just
So basically, you can use any. You can use it for any kind of shapes. So, for example, here is kind of metaball. So it's started from a sphere, then deform it to some torus, and it's
a lot of hard-coded values.
maybe.
Sure.
What are those? What is negative 0.132?
This is generated by actually by JavaScript. What I have done here, I generated.
You made it?
Yes, I made it.
So how is the animation done?
Animation is just the time, and it's a time.
And coordinates.
Yeah, I'm generated at first. I'm generated points. The task was actually here. The task is to visualize community and how community is merged together. And so the task was to generate different points around the circle, and later some points should connect with each other, and then connect to one point, and then this point should be torus.
Yeah.
A donut. And what I have done, I just make some code from JavaScript.
What do you mean from JavaScript?
I just created these points. What look at this.
Yeah.
This random stuff. Just created it by JavaScript.
It's just random numbers.
Yes, it's
Okay.
just random numbers.
Got it.
It's exactly that I wanted.
Mm-hmm.
Some random numbers, and it should be just.
I'm glad to hear you generated by JavaScript and didn't type it.
Huh?
I thought you typed it from your...
Yes, I have somewhere is this generator, but maybe I am even lost. Maybe I have in GitHub somewhere. I just don't remember.
You have to.
Yes, GitHub. I don't know. I will try to find it. I'm not sure that I have it. Ah, yeah, I have. So, okay. I also tried in Zig. Do you know Zig language? Yeah. No. So somewhere I have a generator. I don't know. Wait. Jill again. Yeah. Look. So I have a range, Gauss, normalize, template. Again one. Ah. Yeah, I think this is generated the first shader.
And just console log.
Ah, here actually points.
Why did you choose to do it this way and not just like?
Oh, here community. Look, look at this. Yes, this is generator. This is kind of. Why I choose it things like that, because I was too lazy to generate.
How many values did you have to generate though? Just like this position?
Yes, just like 10, but I don't know. I decided that it will be really random. That's why
Yeah,
I generated this text by this community functions.
Nice.
Yeah. Also, I'm basically I generated everything by this. Yeah. So I have also.
I think I didn't
I have-
see anybody who generates shaders by generatively generating shaders.
No. It's actually okay.
It's okay. Yeah, it's okay.
Yeah.
It's
works.
very good.
Wow, this is so cool. This one.
So I don't think that it's so rare, because I saw what people are making from generative designs, kind of.
Is there a concept of camera in this situation?
Yes.
Like if you can move the camera closer?
Yes. Look, I am moving camera by.
Okay.
Oh, look, this one actually running at 30 FPS.
Mm-hmm.
So it's
Yeah,
a little bit slow, yeah.
It's a little bit slow, yes.
Can you zoom with this camera?
I can zoom, but not by.
Yeah, if you zoom in, you will not see those clipping dots, like they will poof, poof, poof. If you just zoom a little bit, it will be kind of.
Oh wait, are you gonna
Seamless?
code zoom now?
Yes.
Nice. Wait, how?
I just using Z coordinate.
Well, you need to map this to the zoom,
To
the
the
scroll
mouse
wheel.
pad.
So Z is kind of. Yes, it's kind of zoom. So I can zoom closely to this sheet.
Yeah, you need to map it to scroll.
So you have fixed camera distance from the center of the stage, and you can just rotate it.
Yes,
Okay.
and I can rotate
And
it.
so if you put like 2 when there's 0, it will move to the right.
Yeah,
In the
exactly.
camera, like
But also you can see the rotation on line
0.4
89.
is a little bit down, yeah.
Line
No.
89 is where the rotation happens. Like it's just, like the whole camera is just programmed right there.
Mm.
On line 89.
Okay.
That's where it's like I mouse, I resolution.
So yeah, I can.
It's just a different language for like basically Ani, 3D or picture manipulation.
What's happening here actually? So we have a really wired fragment shader, and this fragment shader is what is doing. Each pixel of the shader is solving a really complicated thing. So when when a website is trying to render it, when it's going to this quad, it's starting to understand, okay, on this quad we need to use this shader, this fragment shader. And
Well,
this
it's
fragment
running this code on every pixel.
and this fragment shader is
Correct.
so wired. Huh?
Is it correct? For every pixel on this image,
For
it-
every pixel of this image,
it's evaluating this whole thing.
it's huge amount of steps is going on.
All the steps right here.
All of these steps.
For every
yes.
pixel.
For every pixel, for every of this
Yeah.
of this picture, for every pixel of this picture, it's trying to calculate all of this shit. And what is going on here? At the beginning, it's kind of simple. It's just the UV coordinate of this, for example, circle. Then later we have a camera, we have direction, we have sun direction, we have sky direction, we have mouse and direction and camera and sun direction. It's kind of simple before it will go to raycast. Raycast is here, and what is the raycast is function? It's a 4 step. It's a loop. It's a loop. It's a ray marching loop. It's actually what I show you here. It's starting to do these things. A lot of these steps. And how shaders is works actually. It's unloop every 4 loop. So I have 115 steps in this loop. So the shaders, it's unloop every time because it's so stupid.
What if you reduce the number of steps?
It will be probably on this example. It will be okay. Nothing happens.
What about what about 8?
Little bit you can see here an edge. Look. Somehow it's different.
What about 8?
8. Wow.
Whoa. That's weird.
What's 8?
It basically like kind of like I mean it's really meta, but like it's like the number of steps he going deep into that sign distance field
Yeah.
kind of like function.
It's
Like this circles he showed, he tracing into to find basically to define the surface of the object that he's trying to draw, essentially. So if you go low, they become less defined in a way.
Like you're stopping too early.
Yeah, so you're not really like finding that surface in a clear way.
Yeah.
This looks like when you try to do 2D shape blending with basically blur and level clipping. It's like 2D technique if you want to merge two things. You blur them out and then you shrink the levels, and then they have like those connections.
Everything that you can make in 3D, you can make in 2D too.
True.
So actually every 3D graphics, it's basically 2D graphics. Because the screen always 2D, and you always project 3D graphics to 2D. And if you found something interesting in 3D, you always can use it in 2D.
What about 4D?
4D,
You go to cinema, that's it.
you need to project it to do 2D anyway. So maybe I can show some other example.
Oh wow.
So this is basically, look, this is much simpler, this function.
Is it also generated?
Yes, it's also generated by JavaScript.
Very simple.
It's still a
Very
community?
simple function, Pasha.
Ah,
Wait.
Very simple function.
what?
It's very simple function. Simple.
Very simple, yes.
Yeah.
Yes.
Very simple for sure.
What's happening to this community?
It's not a community already,
This
It's
community
just-
having turmoil.
just boiling.
It's just what?
Boiling.
Yes, something happening here. I don't know. So, yeah, these kind of things is yeah. I just want to make this. I need to make this. It's a kind of paid project. Actually, that I done it in GLSL.
Did they told you that you have to use SDF, so that was your choice?
Yeah, they wanted exactly the same, and nobody can understand how to do this. And I say then they have this thing in Blender, and it was a metaball.
Uh-huh. So
Metaball.
they have a.
They have metaball in Blender,
Uh-huh.
and
So-
they come to me and said, we want this into in web.
In the
What?
browser.
In a browser, yes, and I said yes, I can do it, but I need to redone it from the scratch because I don't have a SDFs from a Blender.
Mhm. Did they like the final result?
Yeah, they like it.
What?
And they
What?
put it on their website.
Not sure about that.
Where do you find projects like that?
From my group, I have a group. Node.jl. I'm not sure about that because the war started, you know. And the war started, and then and the war is making all makes everything is become difficult because this guy was from Ukraine,
Mm-hmm.
and at some point they become unable to respond
To communicate.
to communicate, yes, and also at some point, yes, and I say that yes, I understand what is going on here, not you not understand what is going on though. And at some point it is just over. Our conversation is just over. I don't know what's happening.
Why?
I don't know. So yeah. So you can do anything actually with SDFs. So the reason why SDF is so cool, because you can do anything actually.
Whoa.
What is it?
You can do basically glow effects. You can do
Inside of glass.
inside of glass, yes.
How did you make this glass material?
It's just a box.
Oh,
Just cut the.
can you rotate the camera a little bit more?
Yeah.
Look, and this running at like
Fucking hell.
this is 60 FPS.
Uh-huh.
Like refraction stuff
Refractions, yeah.
with glow.
Yeah.
Pretty impressive.
Yeah.
I don't know if they are photorealistic refractions, but they look cool.
Yeah.
It's kind of photorealistic. Not
Can
so
you
much.
change
Not so
the-
much.
Can you change the index of refraction here somewhere?
Yes.
Do you have this specific number?
Yes, of course.
If you get 1.45, it's like real glass or something.
$133 for glass, I think,
Okay. Mm.
and $150 for water or something like that.
And for beer, there is also a different value.
So
That's the IR.
I'm not sure where.
It's just a random number.
Don't
so-
remember.
Set it to 1.
Yeah, if 1, it will be like straight pass through, right?
Yeah, 1 should
No.
set pass through.
It
This
seems
is
that
Fresno.
it's just I don't know. I think it's another
It's probably in that refract function.
in here glass. I have a glass. Okay, here.
No, 145. See, you go right.
I already have a glass. So here.
Set it to 1.
Okay.
Can you set it to 1? Oh yeah, so let's
Okay.
just pass through.
And what happens with 4?
Crazy shit happens.
With four.
With 4?
No, like 4.
4.
Wow.
It looks
Wait.
super wonky. No.
Physics breaks with 4.
Yeah, so, and what happens at 2? Is it the same? Physics applies here a little bit.
Yeah, for sure. But it's not so
Cool.
physically.
It's ray marching, right?
Yes.
Cool.
So you can do anything actually.
Can you do like multiple instances of this cube? And like, can we see through one cube looking to the second cube?
Of course.
Okay, let's go for it.
So in Unreal, Blender, or software like that, they use ray
It's
marching.
insanely computationally heavy.
They use ray marching to render volumes and stuff like that. Like if you have a volumetric things, they usually use ray marching to display it on the board. What are you doing now?
Making 3 cubes, I guess.
No. Making a ray. Whoa.
Okay.
Oh!
Whoa.
Yay, nice.
Disintegration.
Wait, what? What did you do?
This is a project for Wayne Enterprise.
I lost the cube.
So okay, we somehow should make more cubes.
Is math like the main function?
I think we can do it like that. I will copy paste it from here. So here, for example.
But there's only one W.
Oh wait, you replicated all these cubes? It's crazy. This is such a fucking
W!
this is such a fucking wizardry. It's just changing numbers and like what the fuck?
Okay, sorry. I have a map 2 here. Map 2 is not just
Map 2 is mapping the W.
map is here, okay. It's just a box, yes. And later we have not only box but also W. text. Yes, we have a text solution. So to make
this full
this work,
function to make the W?
yeah.
And it's also generated?
Yes. By the way, this. Oh, okay. This already looks like
Oh, that's great.
that we need.
What about the zoom of the camera?
We can change it.
Oh, nice. So good.
Only one W in the middle.
What?
Can you leave only one W in the middle?
Yes, of course.
What do you mean of course?
Okay.
Where?
Oh.
Wait, you didn't show us
This
the W.
is life coin right here.
Wait, show us the W.
Yes, it's there.
The depth of refraction doesn't get us to.
But
W.
the reason it's actually not a real refractions, as you see that the steps out here is not enough. It's just one step inside a box, and if it is there nothing, it's not showing anything. But yeah, you understand that it's not real actually. If you want a real something, I can show you a real, how real.
You look at this. Yeah.
Oh, guys, whoever is still here alive, just for next week.
Here, a transparent cloud. This is real refractions.
Pasha, I want to make an announcement. So for next week, if somebody want to make a presentation of any kind, it doesn't have to be, like there's no agenda. So it can be 2D, 3D, anything related to graphics. So just send me a message on Telegram.
Okay. So here we have
Wait, this is SoundCloud.
Yeah.
SoundCloud, yes. So I have a different kind of SoundCloud actually. This is the first that I've started from here, and I think Apple is still my design of this SoundCloud. Yes.
Apple?
Yes, Apple. Apple is Apple 12 maybe. Yeah. This this from another artist too. So it's not a joke actually.
I mean, obviously they steal.
Apple stole
They
everything,
still
but
in
they
designs.
made it better.
They still in design.
So,
Huh?
Wait, where's yours? You think the screensaver in this one?
iPhone.
bad artist copy, good artist steal.
Yeah, exactly. iPhone 12 and
Mhm. That was something just production manager once said, and now artists use it as an excuse.
yeah. Oh, here, look. This is exactly mine shader actually. When I posted it in a
Send fucking nukes to.
look at this picture. This picture looks like my shader actually. So, what's wrong? It looks the same. Look.
Wait, give us the angle. Make the angle.
From other side.
From another side.
From that side, yeah. And zoom.
I can zoom to.
Nice, thanks.
So we have these kind of pictures. I don't know how they come up with this idea, but it really looks like Mac shader. And it was, if you remember this announcement, it was with these orange pictures, and then later they showing this green and this and another one, and all of this stuff. But the orange was the main. It was this, and it's actually the funny, but then it's not. They not steal only from me. Later, in 11 iPhone 13, they steal again. And they take this picture, and this picture is also.
Actually, when they did the presentation of this, I took it as screenshots as the best fucking reference. Yeah, this one.
Wait,
Yes.
Who did they steal from?
And
Who
this they steal it too.
Who is it?
It was another guy. It was a generative art guy. I don't know exactly. I forgot the name of the artist. But yes, also exist artists for this shit also. And he's starting to draw these kind of lines, and later he saw iPhone 13 with this kind of lines.
What is your favorite project from FreeJS page?
Can you imagine? From FreeJS?
Yeah.
I don't know. Maybe. Maybe this one.
This is by Ethan Kwong. This is his website, his studio.
Yeah, by illusion.
He's pretty good. He used Houdini as well. for all
Yes,
his shit.
he is Houdini. Yes,
Yeah.
exactly. Yes, he is Houdini.
He's a little bit an asshole though.
Huh?
He's a little bit of an asshole.
Yes,
Yeah.
this is for sure. He's an asshole, yes. Just a guy who wants some money, I think. This project, I think he steal from me.
Have you seen your Tesla presentation? They also stole it. I'm sorry.
Because I am first who making this. Actually, not only this, but just steal from me repeatedly two projects in 1 week, and I just what the fuck is going on? It's not just one project; it's two projects for me.
This piece of shit.
What's the other one?
I can't see here right now it, but it's just transparency. It's multiple transparency. So yeah, I created this kind of font. I don't know why it's not so.
Also SDF?
Yes, it's also SDF. I created a font actually from SDF. This kind of things is just all SDFs.
Mm-hmm.
Each letter, it's SDF, and you can use it like a global global illumination thing. Yes, and you can use it like
Can you share your Twitter on the group? It's not a problem.
yeah. Of course.
You post there, right? Sometimes?
Yes, I'm posting there sometimes. So like post it here. Oh, I don't know what's happened. Nothing shows for some reason. I don't know.
That's okay.
Okay. So yeah, you can do stuff like that. You can do anything actually. This is interesting. This is the future, I think, of all this shader stuff, because as you can see here,
It's a very simple function.
It's a very simple function.
it's just a bunny. And this
What the
is
fuck are those numbers? in
They're
this
probably
function?
just the coordinates, right?
no,
Vertex coordinates?
no, it's called nerf. It's
Those are splines.
it's
No?
it's свертка. It's
No, I don't even know this word in Russian.
Cerca,
the one that's used in CNNs, right? So it's
This is convolutional functions with sinus. With sinus, it's not a symbol.
It's like a compression of right or
No, it's not a compression. It's usually it's just.
It's like signals convolution, but with letters.
Okay.
It's just a matrix multiplied by matrix. I will call it like that. It's just we have some layer of data. We multiply this data, all of these points of this data, to some matrix.
Oh, like a kernel.
Like a kernel, yes, exactly. Like a kernel, we multiplying all of this stuff.
So those
and
numbers.
multiplying again and multiplying again and multiplying again, and we have these kind of numbers. And it is
so
calculated.
Those are the numbers gone through the
It is
kernel.
calculated by artificial intelligence things. It's just a function actually, with some steps, and it's so many FPS. Look. So it's 600 FPS. So it's really fast.
Can you chop his ass off?
Yeah, of course. It's just.
Did you expect a different answer?
Some
Yes.
say you will do it in like 10 words.
It will be one number.
One number. Execute ass chop.
It's just ABS. Oh!
Chop something up.
Yeah.
Wait a minute.
Looks like you shot some
I'm not
balls.
done properly.
Minimize X and
Oh,
No,
it's the other way
no.
around.
Wow. Okay. That happened. So you just eyeballed the coordinates of his ass?
What?
I feel like his ass is 2 points.
Yeah.
What the?
Oh!
So somehow like that I can chop his ass too.
Okay.
I just don't know how exactly. But somehow like that.
Impressive.
How about man?
This is the beauty of this like fundamental math, that once you have like that system, then you can just plug in all this random function in there and like look what happened.
So basically, when you have a bunny, you can do anything with this bunny. Also, you can ray trace it, so you can make a refractions here. You can do anything
How
actually.
did you generate that matrix?
This is generated by artificial intelligence.
So you grab the pre-trained weights and create these kernels?
No, it's not created by me, but it's created by Blackie. It's one girl. And what she have done, what she have take? She have take SDF 3D SDF, and she put it into artificial intelligence. It's called nerf things, and nerf is throw these numbers from it. It's just calculate it a little bit. These artificial things actually not so artificial, not so intelligent, and it's just a functions actually, and it's just minimizing the proper output.
What input can you give to this thing? Like, did you write funny, or like, how did you get it?
So you just take a 3D field. You just take in 3D points of 3D fields, and then later with sinus and cosinus you make in it looks like your SDF.
No, I mean, how did you get this bunny?
He took 3D mesh.
Oh, you gave a 3D
Yeah.
mesh to the model.
No, not 3D mesh, but SDF from 3D mesh.
From 3D mesh.
Yes, but actually at the beginning it was a mesh. Yes.
Oh.
So yeah, this is what I want to do maybe later, some kind of example. I want to take a bottle, for example, or I want to take a human here and make something with it. Yeah.
Yeah, and then you make the full music video.
And then I will
with
make
the human animated and.
Yeah, and then I will make refractions. I will make something with it.
That would be cool.
And Apple will steal it.
Apple will steal it for sure. Apple just steal things.
Oh.
This is Apple as well.
No, it's me.
No, it's Windows 11.
Windows 11!
By the way, you know this?
It's Windows 11!
This is actually the real thing. I'm trying. I'm trying to replicate Windows 11. This is real.
So you stole from Windows 11?
Yes.
You steal from Windows and Apple steals from you.
When Apple steals from me, I started to steal from Windows 11, for example, and I make this shader. Yes, and
cool.
I created it in one shader. Yeah. And then I just.
So this uses some noise, right?
Yeah, I just created special noise for this, and it looks funny. And this is my avatar actually, so it exists in 3D. This from this site, I think. Yeah. So look, actually, what we can do here. We can place here, for example, float, blah 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 blah. So where is much? Where is glow? We have a glow in here. Okay. So for color, we have a glow.
Whoa.
So you can see it's just actually very funny to play with this, with all of this stuff.
Can you output bigger resolution from shader time?
Yeah, of course.
Oh crap.
Yay.
How do you model the glow? Like, what's the function for glow?
It's like a lot of blur closer to the shape and then a little bit blur away from the shape.
No, it's just actually,
Very simple.
yeah. I just somehow like that, yes. So what I doing is just to.
What is your process of finding this kind of like effects? Do you have like an effect in mind, or you like you know how you like, oh, I want some glow, I want some, like, do you find some references, or you like
The glow I found by myself. Actually, the glow that I'm using here, it's not very common. I think only I'm using this glow.
But you found some code, or you found some images like, oh,
I
glow, I want some glow, and
I
you find
found
something.
glow by this paper. I used fractals. I am.
So you often read white papers and you like find something interesting in there and you try to.
No. This is only thing that I found by myself.
Mhm.
Maybe. It's kind of my inventions of how to solve glow very quickly. But glow, you can. It exists a proper way how to calculating glow. You can find it here. And for example, here you can find a glow, but also glow tutorial, I think here exists. Glow tutorial here.
Hmm.
So,
This is also these SDFs?
yeah. It's just a simple, it's just a free line of code and how to make a glow.
I guess glow is a lot easier with SDFs than it is with
Yes.
regular geometry.
Well, with regular geometry, as I understand, the only way to make glow is a post-process step after.
Yeah. But you making a glow, as I remember, on the head of Kiki.
Yeah, but this done with post-processing, I'm pretty sure, in Unreal.
Yeah, and all the
Yeah.
blur effects in real time, they
Yeah.
cost a lot.
Yeah.
Actually, glow is just functions from. So here, for example, glow. Instead of making a glow like that, so the glow here. Oh, okay.
The whole thing is glow.
yeah, the whole thing. Wait a minute, I don't make in a glow here? The thing itself is glow.
It's just natural beauty.
Okay. Yeah, I think it's as you said. But here is not. Here is not, and okay, now again the glow is going from this function that I created especially for this. Yeah, I think. So glow basically is powerful functions. Is here, for example, glow pressure. So here should be some here's some cloud things should happen, and some clouds networks. We have, maybe I don't have connection to Wi-Fi. No, I have, but it's not working for space.
You do, Trader Joe's Wi-Fi.
Ah, okay. So maybe we will see some laser. Ah, okay. As you can see, something happening here. So this is some.
What the fuck?
Can we hear the sound?
I think yes.
Oh,
If we will do like that.
your laptop's dead.
Ah, can we- Oh, I broke everything.
Is there a break?
Yeah. Oh my god, it's 11 over.
Yeah. Wait, is something else you want to show?
What? Ah?
Is there a break?
No. Everything is okay, but for some reason it's going there. So,
It's probably your audio settings.
yeah. But without this, it's going on speakers.